Okay, so here we know that 1 over, if we say that cosecant theta is 1 over sine theta, then we also know that sine theta is equal to 1 over cosecant theta. And so here 1 over cosecant squared theta in this case would be 35. Now, it really, as long as the angles are the same, this really doesn't matter what the angle is. The properties are going to be the same. So we know that cosecant is reciprocal of sine. So we can say here that 1 over cosecant squared theta 35 is the same as sine squared 35 degrees plus cosine squared 35 degrees. Well, we know in our trig identities that sine squared theta plus cosine squared theta equals 1. So we can say that the answer to A is 1. Okay, and now let's take a look at B. Alright, here we have cosine pi over 3 over sine pi over 3. And we know that cosine theta over sine theta is equal to what? You should have said cotangent theta. So we can say that cosine pi over 3 over sine pi over 3 is the same as cotangent of pi over 3. So now we just bring down the minus cotangent of pi over 3. Well, anything minus itself, what do you think that's going to be? You should have said 0. And so this would be, because this is in pi over 3 radians, this will be 0 radians. And that's our answer. So if it's not in degrees, think of it this way. If it's not in degrees, it's in radians. So it doesn't necessarily have to be pi over something. It can just be a number like 2 or 5. Well, if it's not in degrees, it's in radians. So that you want to keep that in mind as you're going through these. Okay, and so if you want to look at these PowerPoint slides later, you can do that. Okay, find the exact values for the trigonometric functions of an angle given one of the functions and the quadrant of the angle. Okay, here we're given sine of 2 over 5. Now notice that this value is positive. So if we're looking at our, oops, I don't want to do that just yet. If you notice that here's our coordinate plane, sine is positive. Sine is like y. Y is positive in quadrants 1 and 2. So we can say 1, quadrants 1. We know this is in either quadrants 1 or 2. But cosine is negative. Well, cosine is like x. And so if we're looking at quadrant 1, quadrant 2, quadrant 3, quadrant 4, cosine is like sine. Well, sine is negative in which two quadrants? Cosine is like x. And x is negative in what two quadrants? You should have said quadrants 2 and 3. So we know that cosine is negative in quadrants 2 and 3. So since their sine and cosine have values that are in quadrant 2, then we must be operating out of quadrant 2. Well, that's helpful to us. What that means is here's our coordinate, cosine and sine. So what that means is we know what sine is. It's 2 over 5. But we don't know what cosine is. Okay, so we don't know what cosine is. Okay, so here's cosine, here's sine. Put those in red. And so we need to find what they are. Find the exact values of each of the remaining 5 trigonometric functions. Well, if we can make a triangle here, we call this theta. Basically, what we have here is we have the unit circle where the radius is 1, and so this 2 over 5, that would be the x value or the y value. We should have said the y value. So basically what we have to do is we have to find the x value. So in order to do that, what we do is we use the Pythagorean theorem. So and that's c squared equals to a squared, or we can say in this case x squared plus y squared for a and b. Well, c is always opposite, side opposite the right or the perpendicular sides. So this will be 1 squared equals to, we don't know what x is, so that's x squared. But we do know what y is, that'll be 2 over 5 and c squared. And so 1 squared, 1 times 1, that's just 1. And so this will be x squared here. And so 2 squared is 4. 5 squared is 25. So now we can go ahead and subtract. We want to solve for x squared, so we've got to apply minus 4 over 25. And a minus 4 over 25 here. And so basically we've got to change that 1 to a 25 over 25 because we need a common denominator. And so now 25 minus 4, that's going to be 21 over 25 equals to x squared. So now we apply the radical. Since we're solving for x, we need plus or minus. Well, now at this point we can split it. Okay, and another thing is, since we are operating out of quadrant 2, is this value going to be positive or negative? Well, because cosine is like x, you should have said negative. And what we're going to do here is we're going to split this. So this will be square root of 20, negative square root of 21 over square root of 25. Well, we can get an even square root of 25, right? Square root of 25 is 5. So we can say that x equals to a negative square root of 21 over 5. And so that's our value for x. Negative square root 21 over 5. Okay, from here, we want to find the remaining trigonometric functions. So we have sine. Go ahead and redo this. Alright, so now we have here, we know that this is 2 over 5, and this is a negative square root 21 over 5. We know this is 1. This is angle. This is theta here. So we can say that this point right here, we know that the y values, that we know that sine is the y value, right? That's 2 over 5. Cosine is the same as the x value. So the x value is negative square root 21 over 5 for this coordinate point. So we know that sine theta is 2 over 5. And we know that cosine theta is a negative square root 21 over 5. Well, we can find our reciprocal identities right away. So the reciprocal for sine is what? You should have said cosecant theta. So the reciprocal of sine is 2 over 5. Cosecant is reciprocal. That must be what? You should have said 5 over 2. And now for cosine, this reciprocal of cosine is secant theta. And so the reciprocal of that would be, the sign is going to be the same. It's going to be negative 5 over square root of 21. But guess what do you think we got to do here? We have to rationalize. So we have to multiply square root of 21 over square root of 21. So this is going to be a negative 5 square root 21 over 20. This will be basically square root of 21 squared, which will just be 21. Okay, so that's secant. Alright, now tangent theta, we know that's sine over cosine, and so that'll be 2 over 5 over negative square root of 21 over 5. So we're taking that denominator, flipping it, and multiply, or apply the reciprocal of the denominator, right? So that'd be 2 over 5 times, and I'm going to use parentheses here, negative 5 over square root of 21. And so can we simplify here? Yeah, the 5s can simplify. They go, 5 goes in the 5 once, 5 goes itself once. So now this will be 2 times negative 1 is a negative 2 over square root of 21. Well, guess what we got to do? That's right. Rationalize the denominator. And so for tangent theta, we're going to get negative 2 square root 21 over 21. Okay. So now for cotangent theta, now it's easiest if you take tangent before you rationalize the denominator. So basically we're looking at negative 2 over 20 square root of 21 and just apply the reciprocal to that. And so that becomes negative square root of 21 over 2. Well, since negative, it's not simplified if the negative's in the denominator, we just put that off to the side. And it's the same thing. And so we have our 6 trigonometric values that we were looking for. And these are, we have 6 answers. Well, actually, we were given sine, so actually we're just looking for 5, but I always like to put all 6 of them down there. Okay, and that's what they did here. We discovered that we were in quadrant 2, and so that means that the x, or cosine, is negative, and so we went ahead and used a slightly different method. Since we went ahead and used the Pythagorean theorem from here, they did a little bit different method, but they got the same answer. And so they get the same values as we do. Okay. Same thing. Okay. And so this is for the values for tangent, cotangent, cosecant, and secant. Okay, here we're given cotangent is 1/3, and sine theta is negative. Alright, well, if we're looking at the unit circle, we know that cotangent, tangent, and cotangent are positive. Since it's sine, cosine over sine, it's going to be quadrant 1 or quadrant 3, because this is positive, positive, negative, and negative. So it's cosine, negative cosine, and negative over negative sine. Negative over negative is a positive. And we know that's a positive. So cotangent is positive because our value is positive. We're operating either in quadrants 1 or 3. Well, sine is like y. Y is negative in quadrants 3 and 4. So both of them have quadrant 3 in it, so we must be operating in quadrant 3. So that's what we're looking at here. Okay. So in this case, cotangent is 1 over 3. Well, so we can say that cotangent is, since tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. So this would be 1 and 3, but we're in the third quadrant, so that must be a -1 and a -3. And so for that, in that case, we need to find what our hypotenuse is. So again, we're going to use x squared plus y squared equals to, in this case, r squared. And so this would be -1 squared plus -3 squared equals to r squared. Well, -1 times -1, that's just 1. And -3 times -3, that's going to be 9. Equals to r squared, so that'll be 10. And so we apply square root to both sides, and the radius is always going to be positive. So this will be a positive square root 10. So we can say this is square root 10 here. So in this case, we're not exactly operating out of the unit circle because we don't have a radius of 1 here, but we can still use the Pythagorean theorem to find it. Okay, so with that, we know we have -1, -3, and the square root of 10. Okay, so this is what we've got. We've got -1, -3, square root of 10. And so sine theta, cosine theta, tangent theta, and cosecant theta, secant theta, and cotangent theta. Okay, we know cotangent, we already said, was 1 over 3 because that was given. So tangent, that must be the reciprocal, right? So that would be what? Should have said 3. So now we want to find sine. Well, sine is opposite over hypotenuse. So this will be opposite is a -3 over hypotenuse. We're looking at this as angle theta. This would be -3 over square root of 10. Well, we have to rationalize that, right? Square root of 10 over square root of 10. So this would be -3 square root 10 over 10. Well, cosecant, just take the value of sine before you rationalize the denominator, and this is going to be what value? You should have said -square root 10 over 3. Okay, cosine is adjacent over hypotenuse. So here's adjacent side is -1 over hypotenuse is square root of 10. And so we have to rationalize that, right? Multiply square root of 10 over square root of 10. We get -square root 10 over 10. And so secant, we apply cosine before we rationalize it, and that's going to be what value? We should have said -square root 10 over 1, right? Or just -square root 10. Okay, and so that's what they get here. We know we're in quadrant 3, and so we know that r is going to be the square root of 10, and so we get these same values here. And then the cosecant, we get the same values for those as well. Okay, use even odd properties to find the exact values of the trigonometric functions. Alright, now when we know that if we work our problems counterclockwise, our angles are positive. Well, if we move our angle in a clockwise direction, our angle is negative. For example, if we have here let's say theta is 30 degrees, then if we were to go in a clockwise direction, this would be negative 30 degrees. Or in this case, this looks more like 60, so we'll use that. And then, so this would be, theta was 60 degrees, and this would be negative 60 degrees, and so on. But it doesn't have to be 60. I just use 60 because it looked closer to 60 degrees. With the even odd properties, when we have sine of a negative theta, then that equals to negative sine theta. In other words, if we have sine of a negative 30 degrees, that would be the same thing as if we were to say negative sine 30 degrees. Well, sine, if we're looking at 30 degrees, square root of 3 over 2, 1/2 for cosine and sine. Sine is going to be, sine is 30 degrees is 1/2, but we have a negative in front, so that'd be negative 1/2, and so on. Cosecant, since it's the reciprocal of sine, the same thing's going to apply there. Now, cosine is different. Cosine, when you have a negative theta, is equal to positive cosine. So if you have a negative angle, you get a positive cosine. So if we have, for example, cosine of a negative 30 degrees, that would be the same thing as if we were to say positive cosine of positive 30 degrees. And cosine 30 degrees is square root 3 over 2. Tangent of a negative theta is going to be negative tangent. And same thing with cotangent. Well, since one more thing here, since secant is the reciprocal of cosine, if tangent of cosine of negative theta is positive cosine, then secant of a negative theta is also going to be positive secant. Okay, so those are even odd properties. So here we have cosine of negative 60 degrees, and so cosine is, we know that cosine with the even odd identities is going to be positive 60. Well, cosine of 60 is 1/2. Okay, so let's look at sine at 390. Well, 390 is the same thing as if we said 360. Well, 360 minus 390 minus 360 is 30. So that's where the 30 and plus 360 come in. Since 360 is a whole 360 degrees around, it goes back to where we started from. We can just eliminate 360 altogether and just say sine at 30 degrees. And since we have sine at negative 390, we can just move that negative out front in front of sine 390, and then we split it, and we get negative sine 30. Well, sine at 30 degrees is square root 3 over 2, so that would be negative square root 3 over 2. And then tangent of 37 pi over 4, since tangent is one period for tangent is pi. Well, we know pi is 4 pi over 4. So basically, what we want to do is we want to find multiples of 4. Well, here we know that tangent of a negative theta is going to be negative tangent and then theta. So that's where the negative tangent and then 37 pi over 4 comes in. Well, increments of 4 would be the next closest increment of 4 to 37 would be 36. So we can say 36 pi over 4 and pi over 4. And so that's where they get this. And so since that's tangent in terms of increments of pi, we can go ahead and just cancel out the 36 pi over 4, and so that gives us a negative tangent of pi over 4. Well, we know tangent pi over 4 is 1, so that'd be negative 1, because there's a negative outside of tangent, this negative here. And so that's what we get here.